Good morning, my good students. Let's begin lesson 8.6b. This is the last lesson in Unit 8, solving exponential equations by graphing. You may remember last lesson we were solving exponential equations algebraically. We would solve them trying to isolate x and find our answer. This time we're going to use a little trick to solve them by graphing. This is helpful sometimes, especially with problems that don't solve easily algebraically. So let's get started. So in our first slide, I want to show you how we can solve exponential functions graphically and give you a four-step process. This is helpful when you're doing your homework. Go back to these 4 steps and say, all right, here's my problem. I want to do first step. First step is let's create 2 tables and substitute in the values -2, -1, 0, 1, and 2. Why those values? Well, for 2 reasons. First of all, they're very simple. It's much easier to plug in numbers like 0, 1, and 2 into equations than to plug in numbers like 237, -49, etc. Also, because we're going to graph them, this keeps our points more in the center of the graph, and it's going to be easier to find our solution. Second, we're going to graph each side of the equation. Now that's kind of confusing. What do you mean, graph each side of the equation? Well, let's suppose, for example, my equation was this. 2x equals 8. Well, when I say graph each side, what I mean is take this side and make it into an equation. Y equals 2 to the x. Then take the other side and make it into an equation. Y equals 8. Okay? So graph each side, so we take one equation and make it into 2 equations. Then when we graph it, we find the intersection points. So for example, if I were just sketching this, what I get is I get a graph y equals 2x looks something like this, and y equals 8 looks something like this, and they cross at that point right there. The solution at this point is the x coordinate of that. This point would actually be the point 3, 8. So my solution of that equation is x equals 3. And obviously you should recognize that 2 to the 3rd power, 2 times 2 times 2 is 8. And that's how this works. All right, so let's try it in our first problem. So I'm looking at the equation 2 to the x plus 2 equals 8. And if I look at the left side here, and I make that into an equation here, I have y equals 2 to the x plus 2, and so we'll use the numbers I suggested, 2, 1, 0, -1, -2. If I put in x equals 2, x to the 2 plus 2 is x to the 2 to the 4th is 16. If I put in 1, x to the 1 plus 2 is 2 to the 3rd, or 8. And notice I'm graphing it over here on the right as we go. If I put in 0, 2 to the 0 plus 2 is 2 squared is 4. And then if we go 2 to the -1 plus 2 is 2 to the 1, 2. And then finally 2 to the -2, 2 to the 0 is 1. Okay. So now we have our graph of our first equation here. My pencil here and just kind of walk through there. Now what's the second side? What's the left side? Well, this one we don't necessarily need to write a table for, but that's y equals 8. In other words, every value of x is 8. So I end up having a line that looks like this to the point. All right. So where does it intersect? Right here at 1, 8. So the answer to my equation is the last step is the x coordinate there, not the 8, the 1. So my answer is x equals 1. All right. And you can see that if you plug it in to check. Let's do a check over here. 2 to the 1 plus 2 is 2 to the 3rd, and that does indeed equal 8. So our answer is x equals 1. Okay. And so in this slide, I show you what the graph looks like if I do it in Desmos. It just looks a little neater than my graph. draws the line more accurately. And there you see where it intersects is the point 1, 8. When x is 1, then 2 to the x plus 2 becomes 2 to the third and does equal 8, and that's our solution. All right, so let's try it again. Let's look first at the left side here to just this equation, y equals 1/3 x to the x power. So when I put it in, 1/3 squared is 1 over 3 squared, which is 1 over 9. And I put that graphic, see I graphed over here, x2, 1 over 9. Just have to kind of estimate it here. Then when x is 1, 1/3 to the 1 power is simply 1/3. Again, we graph it on 1. When we get to the 0 power, anything to the 0 power is 1. So 1 over 1 is 1. And now we graph that. Negative 1. Remember, a negative exponent means I take the reciprocal. So 1 over 3 becomes 3 over 1. And I change it to positive 1. So my answer there is 3. Put the graph there for negative 1, 3. And then finally, 1/3 to the minus 2. Again, the reciprocal of 1/3 is 3 over 1, and I change negative 2 to positive 2. So I have 3 squared, which is 9, and we graph it there. So let's see if I can draw my line here. For some reason, I'm not as good drawing lines to the left as I am to the right. But there we go. That's our graph. Now we're going to graph the other side of the equation, which is simply y equals 9. And that's just a horizontal line at 9. So I put that through there, and you can see, there's where we intersect right there at that point there. So my solution there is negative 2, 9, where they intersect. And what's the x value? The x value is x equals minus 2. Now let's just check it out to make sure it's true. So if I take 1/3 and I take it negative 2, 1/3 to the negative 2 is, again, the negative exponent means I take the reciprocal, 3 over 1, change it to positive 2, and sure enough, 3 squared equals 9. So we've worked the equation successfully. All right? And once again, this is how the solution would look if we did it in Desmos. By the way, anytime you want to, especially when you're doing your homework, if you want to click on desmos.com and enter the equations, you can do the same thing and check your work. Okay, let's try our next equation. All right, let's look at the left side first. And we're going to try, first we're going to graph y equals 3 to the x, okay? So again, I use my simple numbers, 2, 1, 0, minus 1, minus 2. And so we put in 2 first. 3 squared is 9, all right? 3 to the 1 power is 3. 3 to the 0 power is 1. 3 to the minus 1 power is, again, the reciprocal of 3 is 1 over 3 to the positive 1 power. And 3 to the minus 2 is the reciprocal, 1 over 3 to the positive 2, or 1 over 9. So this time let's go over and graph them. And here's our points as we graph the points. And then as I draw my line here, and that's my exponential equation. Now let's look at the right side of the equation, and we have the graph y equals minus 2. That's a line at negative 2 going through. And notice something. What do you notice about these two graphs? Where do they intersect? They never do. You see the red graph here is going to come down here, and it's going to get closer and closer and closer to 0, but it will never get below 0. One of the reasons for that, of course, is you keep multiplying by 3. 3 times 3, no matter how many times, even when you change it to a negative exponent, never makes it negative. So in other words, these two lines are never going to intersect. So what's my solution? There is no solution. Okay. So turning to Desmos, you can see the graph in Desmos. Again, the two lines will never cross. There is no solution. All right, so one more problem like this. Again, what are our steps? We're going to create a table. We're going to list values. And then we're going to graph the two sides, the left side and the right side, and see where they intersect. And the x value will be our solution. So if I look at the left side here, I'm going to have y equals 4 to the x plus 1. So let's list our values quickly. At 4 to the 2 plus 1. 2 plus 1 is 3, so 4 cubed, 4 times 4 is 16, times 4 is 64. Put in x equal 1, and I have 4 to the 1 plus 1, or 4 squared. That's going to be 16, and graph it again here. 4 to the 0 plus 1 is 4 to the 1, or 4. And now 4 to the minus 1 plus 1 is 0, so this is 4 to the 0 is 1. And then finally, to the negative 2 plus 1 is going to be 4 to the negative 1. Take the reciprocal, 1 over 4, keep it 1, and down there. And so here's our graph. Something like this. Okay. Now we're going to take the other side, 16. Where is the graph for y equals 16? Well, it's simply a line, a horizontal line at y equals 16. And you can see then there's our solution right here, 116. So the answer is x equal 1, and that's our solution. When x is 1, as you can see, 4 to the 1 plus 1 is 4 squared, and that does equal 16. And so check, we did it correctly, as I show the check down there below as well. Okay? And so finally, here's the Desmos graph, and again, you can see the solution. The two graphs intersect at 116. The answer is x equal 1 is my solution. Now, up to this point in graphing, most of the times we've been dealing with straight lines, and we found that straight lines can do one of three things. Usually, straight lines will intersect like this and have one solution. But we found that sometimes if they're parallel, they have no solutions, or they could be the same line right on top of each other and they're infinite solutions. Once we start getting into curved lines, though, we have more options than that. And remember that what we said before was the solution was where they intersected. So if you look at problem 16, it says state the value or values of x where f of x equals g of x. Well, where do they equal? Where they intersect. So if I'm looking at my graph here, where do these two lines intersect? And you see one place is right here. And if I look that up, that's approximately the point 4, 2. It also, and that means one solution to my equation is when x equals 4, the two equations are the same. Likewise, though, there's also another solution over here, minus 2, minus 2.5. Fairly simple, and that solution is x equals minus 2. So for this two graphs, the solution where f of x equals g of x, where they intersect, has two answers, and the answers are x equals 4 or x equals minus 2. And so our last problem is just like the other one. You can probably do this on your own, but what you're really looking for is where are the points where they intersect. So as I look here, the first point I see is here at about minus 2, 4, which means my answer, what's the solution? What's the x value of that point? Not 4, it's x equal minus 2. And what's the other value where they intersect? Here at about 2, 1. So that's at the point x equal 2. So I have two solutions where the graphs will be equal, and those answers are x equal minus 2 or 2. And so that's our solution, and that's the end of this lesson. All right. Be sure you review these lessons and review when you're doing your homework, and also review these lessons as you get ready to take the quiz for this chapter. Have a good day.